talk around 15 minutes on the design of TDC and what TDC is about, and then Kishan will give
sorry guys, please keep stuff on mute unless you are the speaker. Okay, welcome everybody. My name is Alexey Kravarov. I'm the founder and organizer of Bay.Area.AI, and this is a joint meetup with SF Spark, Reactive Systems meetup. Kind of, I run a bunch of meetups in the Bay Area, which are about distributed systems, software engineering, and machine learning. And machine learning from the angle of kind of scalable distributed systems angle, not the kind of notebook, it works like on some machine angle, right? So we're deeply interested in where the stuff runs. So D2IQ, formerly Mesosphere, is a longtime partner. They headquartered in San Francisco. And the company, actually, the place in this floor I used to work and run meetups, and we did join meetups there. So long history there, founders. And so Kudo is the operator framework, which was I heard about it first from Ben Hidman, who is one of the founders, and kind of as a new direction. And so from I think from our group standpoint, a lot of machine learning is now understood on a single machine, and the question is how do you run it on many machines? So there's this whole area of MLOps, which kind of encompasses a whole bunch of stuff, including how you run this, how you scale this, how you deploy models and stuff like that. So I'll just, give you a quick example. Like I recently got a book on Kubeflow by Holden Karau, Boris Lublinsky, who I think is in the community now, right, in the chat, and others. And so, Chris Albon is the well-known data scientist. He has is now director of machine learning at Wikipedia, and so he in the foreword he basically says, I know a bunch of data science, and so do you. And if there is one thing we need to learn more about is MLOps, right? So like this is, the set of skills which folks can add to their companies. And so we basically invited D2IQ and Jared Dillon, who is the creator of Kudo, to teach us about Kubernetes, operator framework, all these new ways to scale things up. And I'm assuming a lot of folks here are kind of, there is a mix of data scientists, software engineers. So maybe quick show of hands if you can use the raise hand feature in your chat. How many here are, call themselves kind of software engineers rather than data scientists? Let's kind of see where the divide lies. There is a little show of hand. So okay, I see a couple hands, right? So I would say, yeah, Jared has 2 hands, so he's and kind of okay. So I would assume, right? And let's say how many folks here deploy the service, right? Like if you ever had to make sure a server runs something, and if the server goes down, your job is in trouble, and you get a page, or you look bad. Like if you could raise your hand if your job depends on the server, which should be up, and you might be fired if it's down, right? Like that's kind of very simple criteria. So yes, okay, we have the same set of characters. Basically, got it. Okay, and let's kind of, I'll do the final poll. How many folks deal with Kubernetes in some capacity at their job? Like how many people deal with it? All right, so I would say about the same. Okay, yes, and some people love it. So Boris loves it. Awesome. So okay, guys, so this is Jared. That gives you the lay of the land, right? So I think we kind of have a fairly newbie group of folks who want to take advantage of this stuff. And so, please give us kind of an intro, assuming people know basics of Kubernetes and they're not advanced, right? Advanced users. So, and with that, I introduce Jared. Jared, please tell us about yourself and tell us all about Kubernetes and Kudo. Looking forward to it.
Great. Hey, everyone. Thanks for taking the time out to come listen to this. This is fairly informal. There's I've given forms of this. I think this is kind of a nice blend into reality for Kudo and how it can affect the real world. For whatever reason, my Zoom chat is not opening up. So if anyone has any questions, Alexi, will you just interrupt me if someone types a question?
Yeah, so folks, feel free to put questions in the chat, and then you, Jared, can see the chat, or I can, bring it to your attention. And obviously, at any point, feel free to just declare a Q&A option, and then people can just ask questions.
Great. Okay. Oh yeah. But actually, you know what? It was behind my screen share, so I found it now. I'm testing out Windows subsystem for Linux, so nothing. I'm normally on a Mac, so everything's really unfamiliar for me at this moment. But it's kind of the only way to get like 128 gigs of RAM if you're working on Kubernetes locally. So, okay. So yeah, hey everyone. I'm Jared Dillon. I'm the creator of Kudo. Kudo is short for the Kubernetes Universal Declarative Operator. It's a low-code way or operator-friendly way of building out operators. Here's a whole bunch of stuff. We're on the Kubernetes Slack. There's some demos. I think that demo is actually old. I think what we'll see today is a little more up to date. We have a website. We have a Git repo. We have like something like 850 stars. Healthy CNCF sandbox project, and would love to talk to you about running machine learning workloads on top of Kubernetes today. So quick agenda. I'll introduce myself real quick, just as shortly and without any any build up. We'll talk a little bit about Kubernetes and machine learning. I'm a distributed systems engineer. I'm not an ML engineer, so I focus very heavily on what people want to run on Kubernetes. I'm not. I do not work in any sort of training, serving, data preparation, any of those other sorts of roles. So from a specifics of Kubeflow or anything else, I would defer to those experts. I'm only focused on how to easily run tools like Kubeflow on top of Kubernetes. I want to talk a little bit about stateful workloads and Kubernetes. 2021 is a continued increase in the number of stateful workloads we see on Kubernetes, but we're still in the early days. And we'll talk about some issues with that. We'll lead to Kudo, and I'll do a quick demo, and then we'll go informal chat after this. I can show off CLI stuff in the in a screen share. We can just have discussions, whatever else. I don't want to spend too much time in slides. Hopefully about 30 minutes or so in slides. So yeah, who am I? I'm a systems engineer. I happen to also like distributed systems. Those two things are separate. But talk to me about Rust on one day. Talk to me Erlang Elixir on the other day. But as far as orchestrated workloads, working on systems, that is the things that I work on, and how that blends with infrastructure. And some might call that an infrastructure engineer today. But I'm very much a software engineer first and working on those sorts of problems. I've worked on Kubernetes since pre 1.0, since about Epic. I'm an early developer, contributor, and user of it. And I'm very active in SIG API machinery and CNCF SIG application delivery and the operator working group. There's some leadership changes happening there, but you'll generally find me in various Kubernetes and CNCF areas, continuing to try to contribute, especially towards workloads on top of Kubernetes. And how we advance the state of that and programming models around Kubernetes. Early contributor to Helm 1.0. I helped co-create that, and I created Kudo, the Kubernetes Universal Declarative Operator. So I've been working on Kubernetes now for 6 years. It's 2021-ish, 6-ish years, a little under, and I focus on this very heavily. So happy to answer any questions. So I added a couple slides mostly to frame this talk around why Kubernetes machine learning, Kubernetes stateful applications is important, and then we'll kind of like get through this and get to the meat into what Kudo is, right? So there is a growing need or growing demand within companies to effectively run everything on Kubernetes, right? And that includes machine learning stacks. There's a lot of services out there. There's a lot of ways to run the tooling that all goes into building and serving models. But there's an operational demand out there in the marketplace for actually unifying everyone's stacks. And so I would call this a very early space, right? We're about half as long as into this as we are Kubernetes, and shorter if you think about containers as a whole. And but we are starting to mature. We're starting to think about the full life cycle of applications, right? If you think about machine learning, you have a whole bunch of steps, everywhere from data ingest to munging that data to training your models to actually serving them in your applications. And these are all like different phases of maturity in that, I would say. But we do have some really nice tools that are building upon that, right? So we have this wide focus around a particular use case, right? So if we look at like Kubeflow out there, it's really leading the pathway to ML and Kubernetes. And D2IQ has something around that called Captain. You feel free to look it up, but it's an operator written in Kudo on top of Kubeflow. So we see the demand out here. People want to be able to have this as a one-stop shop to run all these tools on top of Kubernetes. And there's something really important about this that we'll talk about in later slides. Is it's not just the power of running Kubeflow in your production infrastructure. It's that you can lift and shift this and run this on your laptop too, right? You can run this on your desktop computer. And you can do it in the exact same way that your ops teams are doing it in production. Right. So one thing Kubernetes and Kubeflow has enabled us to do is remove that impedance mismatch in your tooling between all those environments. And I think that's a really powerful property. We often very much focus on the software itself, maybe the release of around the software itself, but we do a lot less focus around the ecosystem around, right? And raise your hands if you've ever been in an environment where in production, it had this beautiful CI/CD pipeline, and your development environment was just a mess, right? You may, if you were in an advanced org, you'd clone a repository and run make, and it might work for half your new employees, right? One big benefit that I think goes unrecognized is with Minikube or Kind, you can run the exact same environment on your own environment and know exactly how it's going to work. So okay, great. Okay, you've convinced me in your 20-second discussion about Kubernetes and machine learning. So I have Kubernetes now. Why, who cares? Like, what do I do now? I have Kubernetes, now what, right? So over the past 6 years of Kubernetes, over the past time since Docker came about and Lexi came about, stateful applications have sort of been this unanswered question, or this uncertain background around moving all of your workloads to Kubernetes. You might have your web servers running as containers and then run your database, right? Run Kafka, run everything else on bare VMs, or use managed services, or whatever else. And even in 2020, of the CNCF survey report for 2020, we see that while we're falling to the minority, about half of people are still running stateful workloads outside of Kubernetes, right? Or if you want to flip it, only about 55% of people are running stateful workloads in containers. If we were to go with the postulate, like if we were to postulate that the vast majority of production containers workloads are on Kubernetes right now, we can extrapolate that well across the entire containerization industry, right? So about a little over half are using stateful workloads in production. And there's some reasons for this, right? If we think about our stateless workloads, if we think about the actual apps serving these, the API serving these, they're fairly uncomplicated, right? That's a bundle of code. It's probably calling out to some stateful service that we'll get to in a moment, but by comparison, it's serving a request and response. It might be listening on a queue. It might be performing some actions, but largely our front ends are fairly stateless, right? We don't worry too much outside of maybe sessions where any state in the actual application process is. And so when you start to tackle, so it's actually to close it up, really easy to throw a stateful API onto Kubernetes, call it a day, right? Stateful application lifecycles get a little more complicated. If you look at the tooling out there for Kubernetes today, we'll talk about this a little bit more, but Helm, running kubectl apply, a lot of these really only focus on the part of the lifecycle where you deploy. And if you need something that is persistent, right? This gets into the pets versus cattle description of distributed systems. And for those who aren't familiar with it, if you have a pet, you're going to name it. You're probably going to take care of it when it's sick. We typically use this to refer to databases. And versus cattle, which we typically refer to right now to refer to stateless applications. Something's going wrong with your Rails app, you kill the process, right? You put the cow to pasture, and new cow comes and takes over the work of that old cow. So we built a large amount of skill set on dealing with these stateless applications. Now, as more and more organizations are moving into running stateful applications, tools like Helm, tools like just kubectl apply, we start to recognize only really fit on the deploy part of that lifecycle, right? Whereas stateful application lifecycles are very complicated. Our application's first direct interaction with our database is, other than storing information in the database, is migrations, right? How do we preserve a data model that's up to date at all times? Okay, great. Sure, fine. We'll write something for that. Okay, well, what about upgrades, right? And upgrades is a very tricky thing, right? You have some upgrades that are very straightforward. I go from 2.2 to 2.3 of Kafka. Everyone's happy. Things generally work as we expect them to. Until we get into a, for example, an on-disk change, right? You move major versions of tools and databases that actually require some sort of human migration step in order for it to work, right? And so now it becomes a little more complicated. So upgrades become a very complicated topic, especially since you can't just take the same database file in a lot of instances and say upgrade from Kafka 0.9 to 2.7, today's current version. And so that requires an operator to do. That requires a human to do, to go understand and figure out, how do I manage this upgrade without dropping any messages that are coming into my topics? Or how do I upgrade Cassandra without dropping any data and accept as many writes as I can along the way? And then how do I handle backups and restores, right? As people tend to discover, just snapshotting an EBS volume or cloud volume is not enough. There's plenty of reasons why that fails, but it comes down to the application itself is the only thing that can understand the exact state of your data, right? And there's many reasons for that. Write-ahead logs may have not written a disk. Fsync lies with Postgres and EBS especially. There's a massive issue about that in the past, but even backup and restore isn't as simple as it is. And so what we're starting to settle into when we start talking about stateful application lifecycles is not something that is fully generic, right? You can't just apply the same strategy to every single stateful application with these things. You're really talking about some sort of application awareness, right? And so how do we on one side we have our cattle. We actually don't really care if it's a Rails app, if it's a Node app, if it's a Go app, if it's Spring Boot or whatever else, right? It's a piece of code that's running, it's listening on a port, and it's black box. And we generally only have one pathway to that box, right? A network port. We open that up far more when we have stateful applications. And so how you handle that in containers is a tough deal, right? If a container dies, you usually just replace it. Well, what happens to the data? What happens if I had in-flight migrations, everything else, right? So, and like I said, standard tooling orients around the deploy part of that lifecycle. Great, I spun it up, we're done. we don't worry about the complicated operations that happen after that point. And that's just not true, right? That's where a lot of tooling fails to sort of stand up to that. So how do we get to better stateful applications? Well, for those who are less familiar with Kubernetes, there's a very important tenet that we can take on about Kubernetes, or property about Kubernetes, that sort of reveals its power, and that is it is reconciliation driven, or as we might call it in signal processing, level triggered rather than event triggered. So the difference is APIs in Kubernetes and software in Kubernetes and the Kubernetes ecosystem advances based on a desired end state, not the fact that I want to make the change, right? And this is a very subtle difference. Instead of saying scale to 3, I tell the system I desire 3 replicas, and the system figures out how to scale it for me, right? So if I'm an end user of some sort of stateful application, doing machine learning training, and I might be interacting with Kafka as one of my first data sources, right? Going into Cassandra or something else. In a traditional environment, I might have a Kafka instance. I might have to think about writing backups, restores. I might have to have a scaling runbook and everything else. In a reconciliation-driven or level-triggered world, as the end user, I just ask myself, well, how do I make that as declarative as I can, right? Starting with the version of Kafka that I'm running in this example, right? And then I stop asking to take backups. I'm not in, but I start telling the system, hey, I want backups that are no more than 24 hours old, or 6 hours old, or 1 hour old, right? And then boom, give me an imperative restore status. And then even number of brokers, right? If you go to scale a lot of these tools, especially Paxos RAF-driven ones, scaling is not just a matter of increasing your number of replicas and calling it a day. In a lot of these systems, you actually have to accept the new member as part of the cluster, right? Let all the shards of data sort of rebalance. Let these cluster distributed systems operate as planned, with all the hooks and the extra steps that are needed in order for them to guarantee consistency, right? We want, one interesting thing about containers and stateful driven applications is scaling the number of containers or the number of replicas doesn't necessarily mean doesn't necessarily meet in applications like Kafka's or Cassandra's cap guarantees, right? You actually have to run things in that application. Okay, great. So what if we introduce another layer here? What if we introduce something then to take advantage of this declarative definition and actually start to execute actions for us, so we don't have to execute those actions for ourselves? And this is where operators come in. Operators were originally written about in a CoreOS blog post as they were launching their etcd operator. But really what we're talking about is taking that runbook of operator skills to achieve a desired state and building that into software, so that the steps around achieving those sorts of actions that we want to perform, or those states that we desire, we want something to actually perform those actions repeatably over and over and over again, and reduce the human element in sort of these standard workflows, right? So if we look at that leads to maybe a Kafka operator, right? And we translate that declarative definition into imperative action. So we're going to go upgrade Kafka images. We're going to generate out TLS certificates. We're going to back up and restore your data, right? We're going to automate your DR process. And we're going to do that based on the definitions and facts that you set out from your declarative definitions. So operators have been in play now for a couple of years. They've been here, but there's a lot of challenges, right? Imagine being the person who not only wants to use Kafka, but now needs to write some sort of operations framework for it, right? You need very advanced Kubernetes, and you need a whole bunch of knowledge. You need advanced Kubernetes knowledge, writing controllers, writing custom resources. You need distributed systems knowledge. You need knowledge about the thing you're building, right? You need, if I'm writing a Kafka operator, I need to know everything about Kafka. And the profile we see is we typically talk to people who know a lot about Kafka, but don't want to talk about Kubernetes as much, right? Or they treat that as a deployment target, not its own thing. So that's so building upon that a little bit, right? Anyone familiar with the Kubernetes space, most of it's written in Go, right? And so that's challenge one. There's some frameworks in Java. There's a framework in JavaScript. There's a couple others, one in Elixir, but primarily this development happens in Go, right? And it can be very challenging for people in the space to actually go and hire for these skills, right? If I have my own internal ML pipeline, I don't want to go rewrite all the hand processes that I do today or my bash scripts in Go and learn how to do that on top of Kubernetes. And building a really good operator in Kubernetes takes tens of thousands of lines of code and months, if not years. You end up with code duplication. You have a high maintenance burden. There's typical pathways here that sound great until you actually have to go do them, and you're trying to live like when you're trying to build this software, it can be very difficult to get everything you need to make those sorts of projects successful, right? And what we come to find out is running stateful workloads in Kubernetes way too complicated for many users. And even if you're just going to go out and use operators today, they have completely different workflows, different APIs. If you're going to go run Zookeeper, Kafka, Cassandra, Jupyter Notebook operator, everything else, you're trying to figure out how to operate those all in different ways. They're inconsistently debugging, and you have a whole sprawl of software that runs your software on top of Kubernetes, right? If you consider the fact that if I have a stateful application and I've bought into this pattern that I need an operator for it, well, that scales end to end for however many operators you have, and so all those may have inconsistent services. Now you have 15 operators to deal with on top of 15 different data stores, and that's something that we want to avoid. So with that, I want to introduce Kudo, the Kubernetes Universal Declarative Operator. It's a toolkit and runtime for building operators that are really optimized for these complex stateful applications. We're talking Cassandra, we're talking Jupyter Notebooks, we're talking Spark, right? We're talking Airflow. All of these multi-component systems that have a couple of properties. One, they're distributed and complex in the simplex versus complex sense, where they all interact with each other, right? There's no one consistent braid, and they compose. Right? If you talk about a full ML serving platform, right? Training and serving platform, you have a whole bunch of components there that all need to interact, right? So Kudo is trying to optimize towards that sort of software. And we want to increase developer productivity when building those sorts of operators. We, to put it another way, if you're an expert right now in Kafka, we want you to be an expert in Kafka, not an expert in Go, Kubernetes, and Kafka. And we want, and it's very focused on increasing operator productivity when operating those end services, right? Give everyone using Kudo-based operators a consistent control plane to which they can manage all these services together. So why Kudo? Building operators is very hard work. It requires a very deep understanding of the Kubernetes API. It requires a very deep understanding of all the work and everything that we've put into building operators over the past few years, and all the languages and taking and learn how to take advantage of the momentum that's built up in all the tooling built around Kubernetes over the past couple of years. I don't think people appreciate this enough. That as against I'm fairly against code generation, but it's hard to argue with how strong the ecosystem is when you can just go pick up a whole bunch of types and run with it. The problem is if you don't know Go and you don't really want to write Go all day. I talk about this in another format too, where if everyone built their own operators at this point, we'd all be experts in Kubernetes, but not the thing we originally set out to build the software around, right? So we all don't want to become experts in Kubernetes. Some people have different interests, and so we need to find an easier pathway to actually build these operators. Maintaining these operators is really difficult. So let's say you've gone through all this work and you say, I disagree. I'm going to build an operator in Go. I'm going to use controller runtime and everything. That's all great. And then a new version of Kubernetes comes out, right? You have to deal with all the deprecations. You have to deal with all the new code gen. Typically takes, when we update Kudo, about a week when a new Kubernetes version comes out to sort of suss through all of the changes that happen to enable them for users, right? And so imagine losing that time for every single operator. And I think this contributes very heavily towards the lack of this sort of software out there because the building and maintenance is so hard. And then operating these services is very hard, right? Like there's no really existing solution that is turnkey that lets people easily operate and deploy the services out in production and have a similar control plane for everything they're running. Even though the mechanisms are different, we still want to perform the same sorts of actions on our data stores, on our ML pipelines, no matter what they are, right? And every organization is going to be a little bit different on that. So there's a ton of value in making this a lot easier. So here's how Kudo helps developers for people building operators. If you're going to go build your ML pipeline components on top of Kudo, we provide abstractions for sequencing this complex software, so that you can conceptually take them as similar to runbooks. It's a sequence of steps of how do I actually deploy this application, right? There's some great examples as you go in our operator library. I can show some off as well, but for example, you can separate out the fact that a certificate needs to be generated before you even stand up the software itself, right? And pass information between steps. So there's a little bit of that workflow engine that enables all these steps that you'd normally find in a getting started guide. We're reducing boilerplate and code duplication between all these operators, right? If you have your entire ML pipeline and you have 6 different operators, that doesn't help you. But if you can maintain the operations for that under a single pane of glass, that's a pretty big win and saves hours per week, right? Hours every time you need to touch one of these components. Reducing number of controllers in a cluster. I think this is only important if you're a Kubernetes administrator and trying to operate very leanly. But you reduce the number of software maintaining your software. If you think about an operator, you need one operator for every type of thing that you run. Reducing that is a good thing, right? Because you don't have a Kafka operator, you don't have a Cassandra operator, an Elastic operator, an Airflow operator, everything else. You have one control plane sort of managing it all. We have extension mechanisms. Probably won't talk about that today. We want to be able, I think this is a huge value proposition. When you pick up a lot of these tools, you go to meetups, you get a bunch of you look at a whole bunch of different manuals, best practice guides, you try to figure out how to actually run it, and none of that really gets you ready for your first outage with that, right? Or gets you into the like, how do you know you're production ready? I think what I like about that, I thought, is the way it's production ready is either a company's going to tell that to you, or you have and they're going to own part of that, right? You're paying them, or you're going to sort of get a gauge for that on tribal knowledge. If you can just incorporate this in an easy to go tool, and you make that accessible to companies, then you can ship your best practices for these operations alongside the software, right? Like building that into the operator is a net benefit, because it's something that is, and now you've taken the entire runbook, you've taken documentation, you've taken solutions architects, and you've taken a common pattern and made that repeatable, right? You can ship runbooks alongside their software, and I think that is incredibly powerful once you can start to do that and really focus on what does the end user want to do, right? And we shipped with the testing tool. I won't talk about that today, but we ship with a testing tool for TDD of Kubernetes resources. It's called Kuddle, kuttl.dev. I think Boris, especially like Kudo, might be interested in that. We're trying. It's also CNCF, and it's a really great Kubernetes black box test tool. So how does Kubernetes help Kudo help users? We provide a plugin for Kubernetes for kubectl to deploy, debug, manage workloads. And this is your one-stop shop for managing all of your operators. They're all based on custom resource definitions. And we're working on ways to centralize more of this. We have a lot around metrics and learning story and security in RBAC, but really starting to centralize that so that you have a single pane of glass for all of your operators is where we're going for continued management of all these things that you're running on top of Kudo. Let's see. I think all I'll mention here is that so the way we break out life cycles in Kudo is you have a series of plans. So you might have deploy, you might have update, you might have rotate certs. We have a couple that are built in. Deploy, update, and upgrade are all built in and represent base CLI actions. But arbitrary plans are supported so that if you need to do something like backup, you can write a backup plan, right? And that's the intent there. These can happen in phases, and then phases break down into steps. And why this becomes important is let's this gives you two forms of workflow management, one very granular and one much more coarse. So from a course perspective, course management, you might want to go generate out a TLS cert as a phase and then deploy with that TLS cert, right? In your steps, you might actually deploy out your entire application. So two different grouping mechanisms. You could technically move this into one grouping mechanism. Every time we find out from a semantic level, having this phase, this coarse-grained phase, ended up being a useful decision. So if you're building operators, you have a couple levels of granularity there. I'm going to skip that. I'm going to go to the architecture. So if you're using Kudo, your primary interaction is from the desktop. We have a kubectl Kudo plugin that I'll show off in just a moment. And what it does is it interacts with our operator repositories. These look a lot like Helm chart repositories. They're easy to air gap. They're easy to put into your own environments. But it's ultimately a library of these operators. And then from there, that we get that operator and we deploy that into your cluster and have a whole set of series from operator, operator version to instance that ultimately is an abstract representation of what you want to deploy. And I apologize, I have to bio break real quick and I'll come right back. Can we take a 5-minute break, Alexi?
For sure, absolutely.
Okay, I'll be right back.
Boris, I wonder if you're here. Maybe we guys can have some kind of chat. Meanwhile, if you're so inclined. So I'm personally rather new to Kubernetes, so I wonder if anybody can share. So I'm curious, right? When a new version of Kubernetes comes out, something like Kudo, is updated, and I'll ask Jared when he comes back, right? Like what are the things which are pain points for general developers, which things like Kudo abstract from, right? So what are the kind of fast moving pieces of Kubernetes which change now, which are pain points for developers, if folks have experience with it?
It's not actually Kubernetes. Kudos doesn't really help there. It's changes to the application where operators help. It's actually a little bit worse because with the new releases of Kubernetes, the APIs will slightly change. So all of a sudden, some of the operators are broken.
All right, I'm back.
Jared, yes. Meanwhile, I asked a question. Maybe you can share your perspective. I was curious. You mentioned that Kudo kind of protects developers from new releases of Kubernetes, right? So it takes you much faster to adjust it to new releases than each individual developers would. So I was asking, what are the fast-moving pieces when a Kubernetes release happens? What do you like? What does it entail? That like week for the tuning Kudo to the next release.
Yeah, so you end up with a diamond dependency problem, and I can just draw it on these slides real quick, because let's imagine we have I'll just open up a new slide. Here we go. So we have a Kubernetes version. I'm just gonna write it. I'm not gonna make it look pretty at all. So we have a Kubernetes version, right? And these are like the core libraries that get tagged in the Kubernetes repo itself. But what happens is you have a whole bunch of software that depends on that base Kubernetes version. So you have a client, you have like the API machinery subpackage, and a whole bunch of stuff that's moving out into other GitHub repositories. The problem is, if I were to do some arrows here, and I'll even add controller runtime, because I work on controller runtime as well. The problem is you end up in these diamond dependency issues. So let's say Kubernetes is updated. These are all dependents on core Kubernetes libraries for data types and other things. So if I have my operator down at the bottom of this whole chain, the problem is my operator might be a dependent of any number of these things. And so I can form diamond dependencies, right? Let's say client Go is updated to Kubernetes 1.2.1 or 1.21, but controller runtime is still behind, right? Now I have a diamond dependency issue that I have to now go sort out for every one of my operators. If I'm using Go modules, I might have to use some funky replace blocks. It can be very messy trying to make this dependency tree work. And so one nice thing about using Kudo is that you're not even thinking about this dependency tree, right? Your current version of Kudo is going to work. When you update Kudo, it's going to work. You don't have to go upgrade your manifests because of a Kubernetes update. Now, that's not entirely true. Like if there's a resource type that has changed its version and you're using it as an operator, you'll need to go change that. But you don't need to go change like API level code, right? You're not going to go muck about trying to solve this diamond dependency issue. Boris, does that kind of did that land? I wasn't here for the answer, your answer, but did that?
My answer was slightly different. My answer was that operator implementation absorbs the changes in the Kubernetes, so it minimizes the changes for your software.
Yes. Yeah. No, I think we're on this. We're on the same page. So yeah. Kudo sort of like Kudo takes all of this, right, and then creates an alternative implementation. It creates a data-oriented implementation language for what you might write in Go, right? So you in this case, this would look like Kudo here, right? Dealing with all this, and then you have Alexi's cool operator depending on Kudo. And since you're not using any Go, we can control this issue at the Kudo level. Sometimes it causes a mess, but it's far better than having to do that one specific example I have for this, by the way, and I don't know if anyone else here has dealt with this, but when the Kubernetes Go clients added Go's context in as a parameter, people wanted updates to that, needed to change just about every single one of their call sites and function signatures to handle the fact that now every single API call took a Go context. And so imagine doing that if you're running 5-10 operators. Imagine doing that over and over and over again, that same sort of upgrade on all of your software. Those sorts of changes can be very painful. All right. Any other questions, or I'll continue? And great. Okay. So we have a CLI. If you look on the Kudo site, there's installation instructions for every platform. But it's a kubectl plugin. You can initialize it. You can install packages. You can look at the plans and how the graph will sort of get resolved and steps will occur. You can see how that ended up happening. You can see the status to make sure that everything's up and running and working as expected. We have an open governance model. We use KEPs. We really are all about all ease of contribution. We want people to contribute. We want people to be part of this, thinking about it. We have a bunch of reference operators. We have tons of releases. This is out of date. We're a decently popular CNCF sandbox project. And what we're doing as part of the sandbox is trying to better understand how people run stateful applications on Kubernetes and adapt to that, right? So we want to be the best framework out there for rapid operator development that keeps people focused on their own domain expertise and not having to learn Kubernetes and Go as a whole separate thing as well. I'm going to skip some of these verses. I'll post the slides so that everyone has them. I just want to be cognizant of time here. We have a bunch of operators. I think this is a repeat, right? We're looking more at how do we improve this day 2 story? How do we improve people's day 2 ability to perform actions, backups, restores, and extend upon that? And then we have a whole bunch of operators that are working with this: Kafka, Cassandra, Spark. There's also a Kubeflow operator that D2IQ maintains. We're checking out. That wraps up a whole bunch of these components, as well as the Kubeflow components, and distributes them as well. So thanks everyone. I'm going to switch over for a quick demo showing a deployment of Cassandra and Kafka, and then I guess turn it back over to Lexi or answer anyone's questions or discussion, and then turn it back over.
Yeah, thanks, Jared. That was very cool overview of Kubernetes and operators. I guess let's see if folks have questions.
Yeah, in the meantime, I'm going to do a quick install of Zookeeper. Oops.
In order to have Kudo as a kube control option, do you first have to install Kudo itself? Is it?
Yeah. So it's a binary that's called kubectl Kudo. So they use Git style plugins inside of kubectl. So yeah, we distribute binaries for every platform. As long as it's in your path, it'll and kubectl can find it, it'll be installed as a plugin.
Nice. So it's just a binary, basically, like you just need to have binary wherever you run kube control, and then it will be.
Exactly, yeah. And there's a package manager for Kubernetes called Krew, Krew, that allows you to go find these kubectl plugins, and Kudo and plenty of other great tools are on that as well. I put that into the Zoom chat.
Is Linux Brew like homebrew on Mac? Is it just like a package manager for Linux getting stuff for you?
Oh no, this is the same as Homebrew. Yes, this is so Homebrew and Linux Brew the same thing. It's just a different tap, I guess, in the same repository.
Nice.
But I installed the same way. I went to brew.sh. I ran the curl and everything else.
Wow, that's cool.
Yeah. So if I get my pods now, I have I'm doing some cluster API stuff. But if you look here, we have our running Zookeeper instance, and now I can go install Kafka. The interesting thing about Kafka here, so one thing that we do and very focus very heavily on is this ability to do things either in parallel or serially. You can't necessarily just run. This should work once the search generates. So if you notice here, it started off generating a certificate. If I were to go look at the plan status, Kudo plan status instance equals Kafka instance, we can see here now that we have a we're running the deploy plan. We're doing a serial deploy, and so what serial deploy means is it'll deploy every single instance of Kafka one at a time. This may take a few minutes because it's also doing yeah, it's letting the TLS certificates all generate. But it's going to deploy Kafka 0, Kafka 1, Kafka 2 all serially and join them into the cluster, right? Because that's a manual step with something like Kafka, like something like etcd and whatnot. And so having this ability to have a directed acyclic graph of all your plans and how everything's supposed to like pull together is really powerful when working with this sort of stateful software. And then coming to Kudo soon is stuff like support bundles, right? Like not only to let people ship the run book with it, but also all the support information with it, right? So you can say like, hey, kubectl Kudo diagnose this Cassandra instance, right? And it'll create a support bundle. It'll try to tell you best visibility, what it thinks is wrong, but better enabling people to systemize their run books, because I think a lot of organizations spend a lot of time rebuilding this sort of knowledge and keeping it tribal, or otherwise it's inaccessible. And I'm not sure why Kafka's not standing up. I was standing up for me earlier, but hopefully everyone gets the idea. I'm not sure if my kind cluster is messed up from some of the other work I've been doing. So yeah, that's it. That's all I have. I'm happy to answer any questions. I'm happy to engage in as much discussion as we want to have.
Cool, thank you. I mean, I have a kind of general question. I wonder, if maybe it's too vague, but interested in your kind of insights on this. So I'm thinking through an example of stateful machine learning application, right? And so the kind of the last few years, there was this whole cottage industry of model deployment, which I first didn't understand. Why do you really need an industry of model deployment startups, right? And then kind of I realized that essentially like business owners don't know that a model is just a serialized object from a program now, which you kind of store and version differently from the rest, right? So the kind of communicator hubs, like they explain to managers like, here's a model, and then you deploy it, and then you measure some metric, how much money it makes, and if the model is bad, it generates like losses, you quickly roll back, right? So here's kind of like everybody and their brother are making this model deployment startups and systems. So can I use Kudo to write essentially a model deployment application? So the state is the model, and it has a metric, how much money it makes. And if it starts making losses instead of making money, I need to roll back to a previous model. Like if I wonder if it's a good example for Kudo operator. Like I want to write a machine learning deployment, a model deployment operator using Kudo, right? And so my operator will deploy models, and there will be models will have metrics, and if metrics show models are bad, Boris is signaling to me that this is not a good example, but I wonder, I mean, Boris, feel free to join forces here. Like, this is kind of how I see, I have a distributed system, right? And I need to send this like model around, right? Because I run a web e-commerce app, like, and my model is everywhere, right? So I just wonder if this is kind of what can be used.
I think the analogy I'd use is it would be like using Kudo to serve your API by having Kudo run a container for you that runs like Python-m simple HTTP server, right? Like if there's a tool for that model serving, so actually backing up a little, it's not like Kudo, it would not be a good like pachyderm, for example, right? Like, could you string it together because you're just creating arbitrary actions on top of other containers? Yeah, sure. Right. Like there's nothing wrong with that. It's not going to no matter what, you're gonna have to solve that versioning need in a different way, be it either storing it as a Docker container or whatever model tool. Kudo is going to be a better option for orchestrating whatever is backing that sort of tooling.
So in terms of Kafka, or kind of like an upgrade, right? Like everything which is required to upgrade something, and that would be a good use for.
Alexei, as Jared was explaining, the main idea behind Kubernetes operators is you don't tell how, you tell what. That's declarative functionality is what is in the heart of the Kubernetes. But this relates not to the applications themselves, but the actions on the applications, deployment being the primary action. Sounds about right, Jared?
Yes.
So Kudo, in this sense, is a framework that allows you to simplify building this deployment and lifecycle management operators for the applications.
Yeah, it's
not the applications themselves.
Yeah, it's an orchestrator first, right? It provides that orchestration layer that, and compared to other orchestrators, it's application aware, right? So you can do, it's thinking in terms of what your application is doing, not just how the topology is laid out. In the fact that you can run commands directly, right? You can do all sorts of things. But yeah, it is not trying to replace any of a tool that you would have covered by an application suited for that purpose. If you want to, Alexei and Boris, if you wanted to, for example, ensure that you deployed Zookeeper first, and then Kafka, and then Cassandra, and then deployed Jupyter, made sure it was well connected, all the ports lined up, like everything was connected well together. And then you had a plan that was going to restore data, like restore your models into whatever serving application that you had. Yeah, that's a great area for Kudo. Kudo itself managing the versioning of your models, not at the right level of abstraction, I guess, for what Kudo is really suited for.
Got it. No, that makes sense. Thanks, guys. I understand now. It's kind of planned. So, like, what can be planned, like, you know, like a graph of actions? That makes sense. Yeah. And I mean, like, pedestrian question, like, is there any preference in which, like, how can I write CUDA, operators in CUDA? Is it Go driven? Can I use Scala, for instance? I like Scala better than Go.
This is all YAML driven, actually. So I'm trying to get to this point where we have where we can do data driven operators and let people focus on what they want to do. So as far as like what they're good at, right? There's been a lot of focus around this being as no code as possible. And if you're going to write code, it's on terms of something that you can package as a container, right? So I don't think Kudo, as of right now, I can say there are no plans for Kudo to include an SDK that is aligned towards any sort of programming language. Because yeah, I'm like a heavy like closurist, right? And so
I'll take Clojure any day over YAML.
Yeah, right. I've been working on like sort of a dynamic framework that uses Eden for trying to define workflow steps and everything. So I'm still playing with that, but I think that would be a great inclusion, right? You can write I've been playing around with an idea of if you can compile it down into WebAssembly, then you can add in your own logic, right? But I think the dance I'm trying to do, or what we're trying to do with Kudo, is not suddenly including a whole bunch of other binaries, right? You want, like, how do you sandbox this properly? How do you allow people to have advanced logic without tying them into an SDK? And if you're going to do that, why not just use operator framework, right? I think in addressing sort of the issues with writing operators in the advanced Kubernetes knowledge and everything else, I think data driven is a good start, and I'm really want to look at what WebAssembly and other tools to allow people to build upon that.
Cool. Oh, that's interesting. Any other questions, folks?
Yeah, Jared, the question that I was dying to ask for the longest period of time. There is Kudo, and there is the framework with Red Hat that allows you to convert any Helm into Kubernetes, into operator. And they seem to be very, very, very similar. What are the main differences between the two? Just bullet points.
Yeah, so operator frameworks Helm mode still ends up generating out a CRD for that Helm chart, which is fine, which is not where we're going. In the Kudo perspective, I eventually wanted to, the pathway for Kudo is dynamic CRD schema management. So if I define an operator, it will manage the CRDs for that for you. If we even do that, we may stick with instance and operator version for all of time. So that's number one. Number two is even though you're doing a Helm operator, it is still a hetero or mono. There's a one-to-one mapping between operator and the software you're trying to operate. Whereas Kudo is, end to end. You can run multiple Kudo controllers and controlled multiple different operator types. It's polymorphic. That's what I'm looking for in that sense. So Kudo is a polymorphic operator, whereas even though you can turn any Helm chart into a Red Hat operator framework operator, it's still monomorphic, right? So you're going to be running one operator for every type of Helm chart you convert. That's a huge difference, and I think also creates different demands upon Kubernetes and CRDs. Those are my main ones at the moment.
What do you mean by dynamic CRDs? Because this is one of the largest problems in the Kubernetes, because CRDs are freaking global.
Oh yeah, it's just yes, it's a complete
And
mess.
it's a mess.
Yeah, I want to. If this all lands right, I want to. Yeah, of course. Thanks, Sachin, for joining. So what I would what I want is, if you have operators registered with Kudo, with the Kudo Kudo's declarative language, that Kudo will manage creating and the lifecycle of the CRDs for that particular operator. We haven't seen much demand for that, so that's why we've sort of stuck with instances. And also there was a bug that needed to be fixed in CRDs with watchers that wouldn't expire when you if you create a CRD, delete it, and recreate it. There was a bug around the watchers, so that's why we didn't do it initially. As far as that watch not expiring properly and then not letting you rewatch. So anyway, ignoring all that, I would like for Kudo to get to the point where it will create the CRDs for your operators for you and then clean them up when there's no more, but also have the abstractions in place to where it will manage any sort of dealing with conversion webhooks for you to the best of its ability, I guess. Still very early, but I mostly want to try to find a way to automate away what I feel is a CRD system that honestly needs to be redesigned. So maybe not the best answer to your question, but I feel the pain. I think I feel the same issues that you're speaking to.
Oh, close enough. You basically convinced me that there is no hope. That's
Yeah, I mean, I think we need to redo the CRD system. I think that'll be the best for it, right? It just,
yeah, because when it comes to versioning and deployment of multiple versions, if they have to have the same CRD's names, everything goes to hell very quickly.
yeah, yeah. I think ultimately we'll sort of be bound in Kudo by, I have a very big interest in what the next version of CRDs look like, because I think it's going to be critical to both the growth of operators, but also how growth and success of operators. But further than that, I think sorting this out will be the first start to undoing the mess that we've gotten ourselves into. I don't think a couple years ago, when we started creating third-party resources, right, before they became CRDs, people were envisioning or imagining how they look today, and there's a lot of issues with CRDs, the way they're implemented and everything else, that makes them very inflexible. So to the best of the ability, I want Kudo to be able to dodge those issues, and
I-
then the Kudo team is involved in like
I think the
iterating that.
problem is not this. I think the problem is operators became too popular for their own good.
Yeah.
And now everybody and their brother is writing its own little operator. So we get overloaded with these little minutia operators all over the place. And it's the usual thing for our industry. If there is a tool, I have to freaking use it. I
Oh
don't
yeah.
know why, but it's important to use it.
Oh yeah. The second it's on Homebrew, and you can install it. Yeah. No, totally.
Cool. Well, thank you guys. I think actually I'll need to run in a few minutes. So unless we have other questions, it will be a wrap. And thank you, Jared, very much for sharing all of this. I think it's really cool. We can play with this. Maybe kind of, it will be interesting to follow up, like, maybe on the next stage of Kudo, next release, or, next of Kubernetes, what happens. So really looking forward to follow this, play with this, and, we'll ask you some questions. So if you guys have some questions, comment under the meetup, we'll get them to Jared. So thank you so much, guys. Thanks. Talk to you later.
Thanks, bye.